Okay, so this answer we're going to need to write as an ordered triple, no problem. But first, okay, so let's set this up. Let's first figure out what variable we want to eliminate. Now, right here, I'm looking. The y's are going to be very easy to eliminate. Okay, so remember, start out with some purpose. Start out with thinking about what process you want to use. What variable looks like it's easier to eliminate here? Looks like it's the y's. And the reason that is because this y has a positive 6, and then these other two are negative 6. They're opposites. All right, so the first thing I'm going to do here is I'm choosing to eliminate the y's. Okay, so I'm choosing to eliminate the y's. And what I'll do then is we do have to use all three equations. So I'm going to take the first one here, 2x plus 6y minus 6z. And I will combine it with the second equation. I think that's lined up pretty good. But I'm also going to take it, let's put it over here, and I'm going to combine it with the third equation as well. Okay, so this is kind of a new system that I'm setting up to eliminate the y's. Right, that's the first thing we did. Now we've set up these two systems, and we're going to solve both of them. And by solve, I mean we're going to eliminate the y's. Okay, so I'm going to add the x's, y's, z's, and constants. And what happens here? Well, I got 2x's plus 4x's, which is 6x's. The y's, they zero out as planned. 6y's minus 6y's is 0. Negative 6z plus 5z would be a negative 1z. And in fact, we can just show that as z, if you want to make that a phantom 1. And then that would equal 4 plus negative 25 is negative 21. So that right there, what I haven't read, that is an equation that I can use now in the system. But the equation it no longer has a y. So I'm now looking at creating a system that has two variables, and I'm going to finish the system with this second set of equations. Okay, so again, the y's, I don't have to do anything with these two equations to force the y's to have opposite coefficients. Be aware, though, if you chose to eliminate the x's at this point, you'd have to multiply this equation, the top one, by 4 in order to force those coefficients of x to be opposites. But for the y's, they're already opposites. We've chosen to eliminate the y's, and so that's what we're going to stick with. One last thing about that, though, is the z's, right? If you were to say, I'm going to eliminate the z's, you'd have to multiply the bottom equation here by 6, all of the terms by 6, in order to get these coefficients of z's to be opposite. So be aware that may happen on the assignment, but this one just happens to work out where the y's are going to eliminate. So let's add each of these together. 2x's plus negative 8x's would be negative 6x's. The y's, 6y minus 6y, zeroes out. Negative 6z plus, that's 1z, that'd be negative 5z's. And that would equal 4 plus 35 is 39. So these two equations that we have in red and purple, I can now use those two to create a system of equations. Now, let's see if we can make that better. So this is what I have, and yeah, that cleaned that up a little bit, but you'll notice here that we can look at the system, 6x minus z equals negative 21, and negative 6x minus 5z equals 39, and we should think, well, if I looked at this and started with just this system, what would I eliminate? And hopefully you can see there that if I choose to eliminate the x's, they will eliminate right away. I don't have to actually multiply the equations by anything. So I'm going to stick with that and add the values together. So 6x plus negative 6x, that zeroes out as planned. That'd be negative 1z plus negative 5z's, that's negative 6z's. And this equals negative 21 plus 39, which is 18. So this is now an equation that I can solve for z. So that's what I will do by dividing both sides by negative 6. So this will tell me what z is. Z equals negative 3. So now that I have that z value, it's very similar to what we saw in that last problem, but we had to work to get to this point, and you can see what we did to get to that point. But I have a z value. I want to solve for only one value, and I can see I've got this red and purple equation. It's part of the system. And so I know if I replace the z's in either one with this z value, I can solve for x. Also, I see that, at least for me, I think the red one's going to be easier. So that's what I'm going to do. I'm going to take that z value and replace it with -3. So this equation then becomes 6x minus -3 equals -21. So let's solve it. I got minus and negative, so I show that as plus. And then I can use the principle of equality, just subtract 3 from both sides to eliminate that +3. So that I can drop my 6x equals, because that zeroes out, -24. And then we'll divide both sides by 6. That will give me just the x. X equals -24 divided by 6 is -4. So I now have an x value. I have a z value. All I'm missing is a y value. Now, I can't use the red or the purple equation to solve for y because there is no y's. We eliminated the y's as we had planned. So this means I've got to go back to one of the original equations. Doesn't matter which one you choose. I'm going to choose the top equation. Okay, so let's go back to the top equation. But now we know the value of x is -4. So let's replace that with -4. And then let's replace the z with the value we found, which is -3. So all I'm going to do is I'm going to solve this equation for y. So 2 times -4 is -8. -6 times -3 is +18. Okay, so I still got the +6y equals the 4 as well. Combine my like terms, -8 and +18 is +10. So now 6y plus 10 equals 4. And we'll subtract 10 from both sides to zero that out. So now 6y, that zeroes out. 4 minus 10 is -6. Hey, that's going to work out real nice because now when I divide both sides by 6, I get the y value is -1. Okay, so I've got my x, y, and z. If they give me true statements for all 3 equations, then I can fill these in, right? So I got my x, which is -4. I got my y, which is -1, and I have my z value at -3. But will it make these true? As it turns out, and I already did this on the calculator, by replacing each of the x's with -4, each of the y's with -1, and each of the z's with -3, I get these answers. Okay, so that means that all 3 equations are true statements. I'm always a little nervous when I do this because if I make mistakes on these, you can see how long this process is, and you kind of have to work backwards to see where you made a mistake. Sometimes it's just typing it into the calculator, so be careful about that too. But when I checked all 3 of them, they gave me correct or true statements on all 3, and we can rest assured that we've done this correct.